Cool. So I'm recording now. If my audio is jacked up, let me know in the comments because I don't trust Discord to let me use my audio in more than one place. So yeah, I'm gonna check one thing real quick. I figured it would be doing that. It is using the wrong microphone. Okay, there we go. Also, I'm trying to get the chat up. Audio sounds good. Audio is fine. Sweet. All right. So, shout out. I think it was Doreen. Was it you that wanted kind of a jump in on iterators and generators? It might have been Gabby. I can't remember who it was. If it was you, just say, yeah, it was me. But iterators and generators are one of those things that are. It was Gabby. Okay, perfect. Iterators are one of my favorite parts of Python. It to me, having used other languages, I feel like they always make iterators really, really complicated because you got to do a lot of things like track where you are through the process. Python makes it relatively simple because you start from the beginning and you keep on going. You can go to individual points, and we'll talk about that a little bit. But to me, iterators are kind of one of the things that makes the easiness of Python a selling point, a truthism. We're going to be talking about a few different iterators. We're going to be talking about tuples. We'll do a quick bonus shout out to name tuples. You might hear me say tuple or tuple interchangeably. No one has given me the correct pronunciation of it, so I bounce between them. We're going to be talking about lists, dictionaries, and then finally sets. The way that I'm going to explain it is based on the knowledge that I have on it. I am not a core Python dev. I don't know what's happening in the background in C land of this. So we're not going to be focusing a lot on the performance of things or how things are working in memory and stuff like that. I think if you're an everyday Python user, that's not really stuff you need to worry too much about, but we'll just kick it off. And we're going to kick it off with tuples. Gabby, feel free to let me know your level of knowledge on this. I'm kind of going off of what Gabby was wanting. So if I'm talking at this at too low of a level or too high of a level, let me know and I'll be happy to dial it up or down as we need to. So the big points about tuples, you wrap them around parentheses, they're immutable. So when we think about iterables, one of the big things we have to think about when we're choosing which iterable we're going to use is whether or not we can change something once we've created it. So for tuples, the answer is no. Once you create that tuple, you cannot change that tuple. You can only create a new tuple. And we look at this example here, just like 1, 2, 3, 4, wrapped inside of parentheses. I made a different example here called days off. I get Saturday and Sunday off. I should probably call this let's see, we'll change this really quick. We'll make this normal days off. I always get Saturday and Sunday off, unless, I'm working or something like that. And then I can print, Saturday and Sunday are my days off. And we do this by referencing the position in which these objects are in. So if we're saying days off, well, and again, we're going to have to change these because, change these real quick. We're going to say our normal days off, the normal day off at position 0 is Saturday, and the normal days off at position 1 is Sunday. So when we print this, we get Saturday and Sundays are my days off. That's easy. But like I said before, the key point of a tuple is that it's immutable, which means no matter what I do, I can't change days off. Well, I can change days off because it doesn't exist. I can't change normal days off. So if I try to do this, I'm still going to get that print of Saturday and Sundays are my days off, but I'm going to get this error that says you can't append to this. You can't change what this is. You can, again, I can reassign a different tuple, including Monday, to normal days off, but I can't modify that existing object that is my normal days off. Now, this is good in some ways and bad in others. What if instead we were asking for a particular set of colors? You know, and I see people write code like this from time to time, and this is where I'm like, I don't know if that's the right move, G. Let's just say, let's do colors. Okay, I mean we could do that. Colors of the rainbow. Thank you, Chat GPT, or not Chat GPT, GitHub Copilot. We're gonna make this a tuple. Let's say I want to get green, but I don't remember what number, what index green is at. Green's at index 3. Cool. I could of course do print colors of the rainbow at index 3. That's going to be green. And we can also talk in a second about iterating through different parts of it. So we get green here. We'll comment all of this just to make it a little bit easier what we're looking at. I kind of talked about this from the, I just mentioned this. We can do a different set. We can do 3 through 5, and that's going to be what? That's going to be green and blue, because it doesn't include whatever that last index is. If I do 3 through 8, we should get okay, we'll get whatever, those are. I can't count. 3 through 9, I'm pretty sure we're going to get a key error at some point. Nope. It'll just keep going until it runs out. And once it runs out, it's cool. We can also just do that 3 colon here, and it'll do the same thing. Because it's just going to iterate. That colon just basically means like take a slice of starting at this index until whatever the next index is. And if we don't provide an index, it's going to keep going. We can also, can we do reverse indexing in tuples? Can we say -1 and have it start from the back? We can. So can we say we want go 2 levels back here? If we do this, we're saying with each step, we want it to go back 1 step. We can also do it the other way. We can say we want to go forward 1 step like this, or if we wanted to do 2, we'll say every time we go forward 2. And I'm going to pause, so I'm talking really fast. Gabby, are you tracking still all the things that I'm doing? Because I know these are things that are, you'll do them, you don't necessarily do them a lot. So I'm like in my head thinking like, am I doing this right? And then again, as I'm playing with this, we'll just, for completion's sake, we'll go backwards, all the way backwards. Okay, cool. So we're going all the way backwards. These are tuples. But again, I forgot what number green is. So imagine you don't have, 8 of these, or 7 of these, you got 35 of them. And now you're like, how do can I just go to like the green position? Maybe green isn't green. Maybe green is like grass or something like that. This could be give colors of the rainbow and something that looks just like them. So red, fire truck in America, orange, a pumpkin, yellow, a squash, green, grass, blue sky, indigo, I don't know, something indigo and violet blueberries. I don't know. So when you have something like that and it's going to be hard to remember the order, this is where using something like a named tuple is going to be more advantageous. And I'm only bringing up named tuples for like a slight minute because I see people try to create tuples and then they forget what the order is and they mess it up. So if we look at this named tuple, this is a thing that we have to import from collections. And what we do is we assign this value and we say it's a named tuple, and then we provide a naming for it and the actual attribute values that we want. Now, these are in order, but that also means that we can assign them out of order here. So I've created this thing called user car colors. This isn't my car. This is some made up car that, I thought about. But I would say my car colors are the interior is red with black trim and the exterior is black. So I can say now, instead of print, my car colors at a particular index, like index 0, that'll work still. It'll get my car colors at interior, but I can specify I want the interior value of my car colors. And we run that, we should get the same thing. Same thing, if we want to change, we can change this exterior. Should work just fine. And we can still do those same things that we were doing before. If we wanted to say in my car colors, we want to just iterate through them, we can still do that. We can still operate it as if it were a tuple, because it is. It's just a tuple with a little bit with a mapping associated to it. So that's tuples. Again, I think a lot of people don't use tuples, and when they do use them, they often use them for things that maybe they shouldn't be using them for, or they're getting back a result and they're just like, I'm going to operate with this tuple and do what I do with it. There historically have been claims that tuples are faster. They're like one of the fastest iterables that you can work with. Tuples, I believe that's still true. I try not to get wrapped up in performance. The way that I would explain it is, if you got data and you don't want that data to ever change, a tuple is the way that you prevent that from happening. Any questions? Feel free to ask the questions if they pop up. If not, we'll move on to the next one, which are lists. These are the things that most people are probably familiar with. Lists and tuples, the way you interact with them are pretty much the same. They're going to be these values that that have an index. You can call them by their index point. I don't think that there's a named lists. That would be a named list. Just sounds like a dictionary, which we will talk about in a second. But here we have this days off again. So let's say for this week, my days off are Saturday and Sunday. We're still doing the same thing that we did with the tuple. It worked just fine. Very much the same. But now if I want to say, oh, I've been told by my boss that Mondays I can get off too. Cool. We can append Monday to our days off. And now if we look at this whole list, we can just say print days off. We don't have to do any of the extra stuff. We should see that Mondays are added to it. We can also insert at particular positions. So we can say, let's see here. We can say days off. We can also, we'll prepend first. Prepend and append are kind of the things that you see the most of. I don't know why we're starting with, one section and going in a different direction. I think it's fine. Usually order can be important, but order is fluffy in this case. List attribute has no prepend. I was wrong. You can't prepend. You can insert. There we go. So when you insert, you say, I want to insert this value, and I want to insert the value at a particular index. And I might have that backwards. I do have this backwards. Insert, you say, I want to insert this at a particular index, and then the value that you want it to be inserted at. So you don't prepend, you just say days off insert at index 0, Friday. And yep, that worked. Again, we print our days off again. We should now see Friday added. And this gives us the ability to then insert. We can insert this at any spot. We want to insert it at position 3. We can do that. You want to insert it at position 2. I don't think, can you do -1? This is an interesting, I'm like questioning all of these things because I don't know the answer. Apparently you can position it at -1, but it didn't do what I thought it would do. I want to see why that does that. I would say most people would insert it 0, or they would insert it at a particular position. And again, if you need to assign a value to this, you probably just want to use a dictionary instead. So again, lists, very much like tuples. The only difference is that lists are mutable, which means that you can change their value. That -1 thing is throwing me off now, but I'm gonna keep it moving. We got decent time. I'm trying to get through these relatively quickly because the second part of this is generators. Generators are a different beast. It's just different in general. Gabby, we still good? I'm gonna just keep going. Now let's look at dictionaries. Dictionaries are dope. Dictionaries, you wrap these in curly braces. Dictionaries give you the ability to change what you've assigned, so they're mutable, and they work in the form of key value. So I'm gonna add that to that. So going back to our car analogy here, I have this slightly complex dictionary here that's called My Car Configurator, and it's not just the colors. We have our interior color, our exterior color, our wheel style, our wheel size, whether or not it has a sunroof, and what type of spoiler it has. So this object here, this is just a dictionary. This is, we have the key of exterior color and the value of red. And we can operate through these. And I actually haven't talked about iterating through these yet. I will do that at the very end. So let's start with My Car Configurator, the exterior color, and we'll comment out the rest of this just to narrow our focus. Oh, well, that doesn't help if I assigned it. Let's do this. Okay. And we'll print it. And I'm using pretty print just so that it's not all on one line. It's a little bit easier to read. You don't have to use pretty print. I did it to make things a little bit cleaner. Actually, that's fine because it could just be print. Yeah, so it's going to be red. So we can call one of these, but we can't necessarily say My Car Configurator 0, because what that's going to do is that's going to look for some key called 0. That key doesn't exist, so we should get a key error here. Key error 0. That's basically just saying, hey, you tried to make something from the key 0. I don't know what that is. Nice try. You can also just list out the keys themselves. So you can do keys like that. I can never remember how to actually play these, but I'm going to say it's a button. And then you get like this object here that is like a list of the dictionary keys, and then you have all those lists in there. So this is, you can do the same thing with values. We can say print My Car Color or My Car Configurator values. If we do that, we're going to get values, but notice you don't get the keys assigned to them. And there are a few other things that we can do. So we can do, I'm glad Copilot's on my side right now. We can do items, and items will give you kind of a key value association to them. So often what you're going to see is you're going to have these like pairs. Once we start iterating through these, we're going to use this items one a lot. And if you're wanting to iterate through a set of values, you may want to use those items. And this is where you're like, I've got a bunch of dates or a bunch of fields, and I need to get a specific thing, or I need to do something with each of these items. I need to iterate through them and then process them all differently. That's one way of doing it. And again, I'm more trying to explain, I guess, how these operate and how you would work with them more than like what's the appropriate way to do particular things, because I think we could be here for 3 hours just trying to run through all of that. So I mentioned that dictionaries are mutable. This means that if we want to add a value, if we want to add a key value pair, we can do that. We can add transmission. We can say, hey, the transmission on this is manual. If we wanted to add the wheel, if we wanted to change a value, we do it the same way. We just use an existing value and it'll overwrite that. There are some other ways to do this. Like you can use the update. An update will let you change multiple values at once by inserting a different dictionary. What else is in here? There is no, and this is true with all of these, there is no data validation lock on this. So I can't say, well, I know that a manual transmission can't be an electric vehicle because they use different, like electric vehicles don't have standard transmission types like gasoline cars. Dictionary don't care. Dictionary is just going to do what dictionaries do. Also, there is no standardization of what that value needs to be. So if I want my wheel size, instead of 19, I want my wheel size to be like really large, like that works. Dictionary doesn't care. It doesn't matter that before it was an integer and now it's a string. So there is a Python object called a data class where if you want a certain type, you can kind of use that. I'm not calling it an iterator because I think iterators are a little bit different. It's a class object. It's a very simplified class object. It does a lot of things out of the box for you. But once you start thinking of things like that where you need to worry about data validation, that's where dictionaries, you kind of want to shy away from them a little bit more. And of course, like I said, if we can run this whole thing and we'll get, my initial configuration was this. My updated configuration is now this. And we can see where we added a bunch of stuff and things got added. All right. 5 minutes to talk about sets is not enough, but I am going to do my best. Sets are another thing that I think get underused. Sets are great in that they are mutable. So you can add to a set, but sets may only contain unique values. So whereas in a list, I have this animal set here. If I have a list called animals, we'll say animals. Yeah, we'll do that. We can have dog and cat in here as many times as we want. But in our set, it doesn't matter how many times we add, and you would add to a set by using the add method. You would say animals.add. We can add these as many times as we want, but all we're going to get are the two objects. We're just going to get dog and cat. And notice how the order did change in there. That wasn't intentional. So order is not preserved in a set. What I will say is, going back to these, order is preserved in a tuple. Order is preserved in a list. Order is now preserved in a dictionary. It used to not be the case. That is the case now. I don't know how many people would tell you to bet your house on that. So don't depend on the order of a dictionary, but they are technically, the way that the code was written, I think it was a happy accident that now order is now preserved. But in a set, the order can change. The order can move around. Or the order isn't determined on how you enter the data. Maybe it is. Maybe it takes whatever the last value you put in there and nope. Okay. So yeah, it doesn't care. So this is good when you need to get a unique set of like the values. Originally I was thinking of like, all right, if I did a food log and I wanted to just have my log on Monday I ate this, on Tuesday I ate this, on Wednesday I ate this, on Thursday I ate this, but I had these different items in each one, I might take all of those items and move them into a set. And actually, this is going to be a thing that we're going to do kind of as the final exercise in, let me add a code block here in this. So we're going to say types of food. We're going to make this a list. Let's see. I had eggs. I had pork chops. Sorry for those that don't eat pork. I had rice. And I had yogurt. And I had ice cream. Because, of course, I had ice cream. Cool. So, I have this list of items that I want. Now, let's say Monday's meal was, we'll make this a tuple of breakfast, lunch, and dinner. You know, not saying that I should, but, you know, this could be a named tuple. It could be a dictionary. We're just going to make it a tuple. So Monday I had eggs. For lunch, I didn't have anything, so we'll say none. And then for dinner, I had, we'll do a list of chicken and rice. All right, we tracking. So this is what we did on Monday. Everything worked out. Everything ran nice and complete. So we noticed something here. Chicken isn't on our list of food that we have. So we can do, you know, types of food. Append chicken. Okay. So now we know that the types of food that we have in our diet is chicken. It has chicken in it as well. So let's say we went out to eat on Tuesday. Restaurant menu, they have all these things. How do we then start working with some of these different types of objects? So if we just wanted to iterate through the different types of food that we have, we would just use a for loop. We would say for meal in, or for, let's see, food in types of food. Yep. Print food options include, and this is, yeah. So now when we do this, we should see a list of, yeah, all the different foods that we have here. And that's going to pull from this original. It sees that we added chicken to it. So then now chicken is added. It's added at the end because it's the last object. So now we want to see for meal in Monday meal. We can say, we're not going to do all this. We're just going to say print I had meal. Cool. That works. Oh, and see how this operated here. It was like, whoa, dog, you can't add none to this, but what we can do is we can actually put this inside of an F string, and it'll format it as a string, and that should work now. Yeah. Oh, well, it'll also work if I add the F there. Yeah. So I can say I had eggs, I had none, and then I had this weird list of chicken and rice. And all it did was it took whatever this value was and turned it into a string. This is why sometimes type can be important, but it's not necessarily always important. And then, so we've iterated through our tuple, we've iterated through our tuple, we've iterated through our list. How do we iterate through a dictionary? And that's going to be the next step here. Pop into that. And this one, we can't just say, if we wanted to iterate through the keys of the dictionary, we would have to say something similar to, like, we could just say for section in restaurant menu. We don't need to do all that. We can just say print the section. So for section in restaurant menu, print the section. If we do that, we should just get breakfast, lunch, dinner, dessert. Perfect. Cool. If we wanted to get the actual items in that, we could say for food item in restaurant menu dot values, print food item, something along those lines. And that should give us, eggs, pork chops, rice, and ice cream. And then if we wanted to combine those, we would use something like items, where we would say, oh yeah, look, it's saving me time here. For food and food item in restaurant menu items, we could say print f string for section. We have this. We have food item. So for breakfast, we have eggs. For lunch, we have pork chops. For dinner, we have rice. For dessert, we have ice cream. Sometimes you will see people do this strange thing. So we'll say for section in restaurant menu. I think teaching people to use items is probably the right way to go, but you could say for section, we have restaurant menus section. That works. It's going to do the exact same thing. But perhaps it depends on what your preference on readability is. Most people will say use items because items we know is going to give you the section and the food item. And sometimes restaurant menu and section aren't necessarily that cleanly defined. It might be random database log value key and then some value. And then you got to try to remember what that random database log value key thing looks like. Which is where items is. Nice. It also gives you the ability to reassign the variable for each one. I'm definitely not covering the walrus operator because that is way, 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 way beyond what we're doing here. And then let's just say we're going to copy this a little bit. Let's see if we can hit Tuesday. I can't spell Tuesday. Cool, we did that. We're going to intentionally leave out ice cream because I want y'all to think that I have a better diet than what I actually do. Notice that this is longer, so we don't have breakfast, lunch, and dinner. So we can't call these breakfast, lunch, and dinner. We can't identify them as breakfast, lunch, and dinner because now we have these like 4 sections. Maybe the rice was part of a snack or the yogurt was a snack. We don't know. This is where something like a named tuple could be helpful. Because if we import collections, and we say meal is a named tuple, meal, breakfast, lunch, dinner, snack. These are delimited. I forgot what the yeah. That's wild. Okay, well, we can do it that way too. So now we say breakfast, lunch, dinner, snack, cool, like that. So now when we do Monday meal, we're not going to say this anymore. We're just going to do meal. And then we're going to say this is a meal. And now we can actually iterate through breakfast. So we can say for day in, I guess we need to create a list. We'll create a list called, or a tuple called days. I don't know. We can pass this in directly. That's why not. In Monday meal, Tuesday meal. We're gonna print. Yep, for breakfast I had day breakfast. And this should give us a list object is not callable. Oh, that's interesting. Okay, so it's having a problem processing that this list in here. That's okay. Well, cool. We'll clean this up some then. Oh, come on. And then it says none type is now not callable. So this is where you start getting some interesting bugs that pop up. And this is also why you probably shouldn't do this unless you are defining what you want to define. So then we can say, instead of this, we'll just say breakfast is equal to that. And we'll say dinner is equal to that. Does that work? You done yelling at me? Why are you still yelling at me? List object is not callable. If someone sees the issue that I wonder if it's this. I wonder if it's because I tried to define it as a list. Because I thought that was weird. I was like, I don't think I've ever seen that like that, but maybe I was just reading the output of this VS Code block incorrectly. What am I doing here wrong? I only have one square bracket. Oh, no. I just use the word is instead of actually defining, instead of equals. Okay, new mill is missing 2 required positional arguments. So this is a different thing. So this is where you run into that same issue of like, hey, you've said that a tuple has to have a meal, a breakfast, a lunch, a dinner, it has to have a breakfast, a lunch, a dinner, and a snack. You've only defined breakfast and dinner. What about lunch? What about the snack? So now we could say, well, for lunch, I didn't have nothing. And for snack, I didn't have, or I had nothing as well. There we go. and it'll still say for breakfast I had, and we can say for day and meal. Yeah, cool. So this is where, one, live coding is always a nightmare, but two, you can see we're here. I didn't have to care about the order. I didn't have to think about, okay, I have to always write this in the art of breakfast, lunch, dinner, then snack. I could do breakfast, lunch, I had a snack then dinner. But if I don't define it, then it gets added in the order that they were defined in our name tuple. And then we'll just say across the board, we're going to actually write a function here, and we're going to use this function for our generator in the next one. We're going to say for day in Monday meal, Tuesday meal, for meal in day, we're going to say set, let's create an empty set first. We'll say all food eaten. We'll say all types of food. It's just going to be a set. And then if it's an empty set starting out, we'll say all types of food, add that meal. So at that point, now when we print off all types of food, we should see, and just to verify this, we'll say print all type, well, that's a set, and that's two other things. So we'll see this where we had none was an option. None was an option that we had. So maybe you do an if statement here. If not, perfect. Sorry, new keyboard, fighting with it. Okay, so now we've gotten rid of none. So now we can only see that these are the foods that we had. Did I have, yeah. So notice how ice cream is not in here, where up here, ice cream was listed as a type of food, but it wasn't a type of food that I had. And this is where like sets can be great, because I had eggs in, twice in this. I had eggs on Tuesday, I had eggs on Monday. I don't need two instances of eggs. I just need the fact that I had eggs in the list. So this is how you're allowed to use sets really quickly. So we're going to take this code here, and this is kind of the grand finale in this. We're going to talk about generators, and I'm going to need to add some stuff in here. So okay, so we're going to have let's add our days. Let's add our meals that we had before. This Monday meal, this Tuesday meal. We're going to pretend that this is all of our meals for the entire year. That's a pretty big list. And sometimes you got to remember, all of this stuff is happening in your computer's memory. So when you're working with, actually, before I continue on that, Gabby, are you still tracking? I want to make sure, because I know that last part was a little rough. Iterating through lists and stuff can get kind of rough when you start dealing with different types. I see you typing, so I'm being a little patient here. All right. It was a little complex, but you're here. Yeah. Once you start iterating through them, once you start mixing and matching them, it does get a little complex. I would say in most instances, you're probably not going to be running through them so quickly. And it also may just be that I had to think of a way to explain it on the fly. And that was a little tough on my part. Hold on 1 second. There we go. I think we had someone that was unmuted, but I got it. Yeah, if you're not on mute, that would help because my brain cannot process these. All right, so just to wrap the context around where we are, because we had a couple of people just join. We are we're just making this meal planning simple example where we have a meal for the day, which is your breakfast, lunch, a snack you might have had, and dinner. So let's imagine right now we just have Monday and Tuesday. Monday and Tuesday could be dates. It could be, I don't know. Today's the 22nd, so we'll say the 21st. Something like that. And I know that this is where you start looking at databases and stuff like that. I mostly just need some instances of things that we're going to iterate through. We're going to say that we could do this. This is great. This is a good example. We do this, we get, oh boy, what are they yelling at me for now? String object is not callable. I mean, you literally did the thing up here. So why are we fighting with it? 1 second. Dude. I don't think this is the problem, but okay, yeah, it was a problem. So we can run this function, and this function will run pretty quickly because it's not that busy. It's not, too much stuff happening. For breakfast I had, and we can even say for breakfast on day I had, well, actually we can't say for breakfast on day because we didn't define what the day is. But we can say for breakfast I had this, for lunch I had this, for dinner I had this, and then for a snack I had, we're just running through these things. If we had to do this for every day for the last 10 years, if we're iterating through a database list, we don't know how long that database is. So what we may do is we may actually create what's called a generator. Generator is going to require us to write this a little differently because a generator you yield, and when you yield, you're only concerned about the very next item. So in your generator, you're going to have something like generate day meals, something like that. And that's just going to be yep. Well, we're going to do this. We're going to print these. For meal and days, yep. I'm gonna say, I don't want to call this meal because meal would rewrite something. For meals and days, same thing here. Same thing here. And same thing here. All right. And let's get rid of this. So a lot of this seems the same, but what we're going to do is we're going to say yield at the bottom. Now, telling it to yield means that when we run this, we should only get one instance, I believe. We do need to pass the day. Oh, days. So we're going to still give us our tuple of these 2 days. Meal plan takes one positional argument, or 0 positional arguments, but one was given. Oh, yeah. Wrong function call. Generate day meals. So now we get this generator object. This this doesn't help us. We want to see what the days are. So that's fine. What we want to do is we want to say next. And what we should get is we should only get 1 day. So we only get the 1 day. Run it again. We're always only going to get this 1 day. And what this is doing is this is only loading one piece of this in memory at a time. So we're saying, hey, run this entire block and then generate just the first object. If we run this again, we should get, oh, well, yeah. How do we do this? We can say, yes, there's that. There we go. Day mills generate that and then next day mills. So we assign it to a variable and we say, give me an object. If we say, give me the next object, we should see that they're different now. Yeah, there we go. So what we've done here is we've said this generator, assign it to a variable. Because again, if we try to print what day mills is, we're just going to get a generator. We're going to get this generator object right there. And that's this position in memory. When we do next, we're only going to get the next item in day mills, which would be that first day. And we can even make that a little bit easier. Day, and we'll go there. So just so it's easier to see that what we're doing. We'll say day is equal to March 21. And here we'll say March 22 and keep it moving. Oh. There we go. We'll also just add some space in here just so that it's easier to read. There we go. So now we can say on March 21st, we had this. On March 22nd, we had this. And we notice that it's different. And if we remove that second call, we only get the first object. So this is a way that when you're working with a bunch of data, you're only loading one bit of that data in memory at a time. This is really good in my job, what I do with database, like I work with databases. Often we have to index, several thousands of rows of data at one time. And actually I can show you what that looks like in like a small sample. Because I got it open right over here. So I'm not going to actually run this because it would not run anyway. But we can look and see here. This is a function that I wrote this morning. I had to, missed a piece of this for it to make sense. I had to take some data that was in a CSV file. There are 25,000 rows in this CSV file. The rows are kind of complex, as you can see. I needed to transform this into a pattern that could be used by our database. So what I did is I created this generator called load data, and it basically says, hey, start iterating through the articles in this CSV file. Start iterating through those rows. And for each row you get to, I want you to give me this information. And then, again, I'm trying to make sure I'm sharing A, what I can share, and B, what makes sense to share. Ignore the seek thing because that's just some CSS nightmare stuff. So now I can say, we're going to do this bulk upload thing where we're going to bulk index all of these pieces of data. But what I want you to do is I want you to take my client, which is our database connection, and I want you to go through each of these rows, and I want you to index them into the database. I want you to add them to our index here. I want you to basically pass this information in. And this is where we're able to say, we're doing this 25,000 times. If I had to store all of that in memory and load once, on my computer, would it work? Maybe. On a Raspberry Pi, probably not. Or I don't even have to worry about how big the device is because I'm only loading one of these objects in at a time. So as we're hitting the hour, I wanted to end it with that because what we're looking at is all of this stuff is iterable. All this stuff can be iterated through. Even with this generator, we can still iterate through it. We could say day meals are this for meal, for day in day meals, print this is the next day, something like that. And it'll still run like we did before. So we get everything happening. We get this is the next day. The next one, boom, this is the next day. We're still able to loop through this because a generator is an iterator. But we're only loading these things when we need to load them. I like, Doreen, this is super awesome, especially on memory management. It's the main reason you use generators when reading data. Reading data is hard, especially when you don't know the size of the data that you're reading. It's also good for ingesting data too. So if you have data and you got to do something with that data, we're just printing. We're just printing stuff here. What if I had to, do some Chat GPT, do a thing, if every single one of these was called and we'd have to go into Chat GPT, now we're going to have to wait. We're going to have to store all that information. That information is going to have to sit in memory. And if we don't need to do that, we're just wasting memory, which could be really important if you're using something like Azure Functions. You talked about going into data science. So if you're using something like Google Cloud Run to, put stuff into big data or Google Data Lake, or if you want to use something like Azure OpenAI, a lot of these processes, the harder your system is running, the longer your system has to run, then the more money it's going to cost you. So ultimately, at the end, you're trying to do things as optimal as possible because optimization is going to mean if you use a generator, instead of storing everything in memory, you don't need as much memory, which can lower the amount of resources that you have to get. And at the end of the day, it saves you money. Any questions, feel free to come off mute. Feel free to ask a question as it may have popped up. Happy to answer them here. And if you don't have a question, that's fine too. But okay. I see some folks typing. Just a reminder, I am going to try to clean this up a little bit and put it in a Jupyter notebook or, the repo on GitHub or something. Thank you. Thank you for the presentation. Kudos there. It's one of those things that the reason I think it's important to go through this again over time is I forget how things work from time to time. And I think most developers do. And again, doing this for 9 years, some things have changed. I talked about dictionaries. Dictionaries changed a few years ago, in which order is now kind of preserved. Again, don't base your entire program on that knowledge, because someone's going to use some older version of Python and then it's not going to work. But this is going through the basics, running through them again is super helpful. To wrap this up, next week we're going to be going through CFPs. The good, the bad, and the non-controllable of CFPs. I think that is going to be super beneficial for some folks. If you have gotten a slew of rejections for your conference presentations, this is hopefully going to help. It is not meant to be a surefire win. I told this in a PyCon interview that I had to do. I have never had a talk accepted at PyCon. I have spoken at so many other places, but PyCon US is not one of them. And now PyCon is asking me to get up on stage and speak. So there are different styles of presentations that do better at different conferences. My style probably doesn't play well at PyCon that well, because I like to do stuff like this. I like to do stuff that's fun and engaging. I'm here to talk about Python versus hip hop. I'm not here to talk about like the latest and greatest optimization error that came with Python 3.12. So, but that being said, I've given talks at a lot of conferences, and the biggest thing that helped me was learning that I can only control so much of the process of having my talk selected. And no matter how good or bad I do, I may not be able to, like, my talk may not have been selected for reasons that are beyond it was a good talk. It might be something behind the scenes or something financial or some, like they just had another talk that was exactly the same and they wanted to give a shot for someone who had never given a talk before. So like I said, if you want to hear more about that, that's going to be next week. I don't know if it's going to be the same time. Just check the events thing in Discord. Time zones are weird, and I know that time changes are happening all over the place, so it'll be whatever time it's in the Discord events thing. And also, if you have a topic that you want covered, just put it in the chat or put it in general. That's the best way to do it. And I take a week to learn this stuff. Or if you want to present something, actually that's the better solution. If you want to present something, come in and show us. We'll give you an hour to come in here and show us what you got and tell us what you know. And what I will say is you don't have to be an expert. Just share what you know. And if you make a mistake, you make a mistake. I made like 7 mistakes in here, so like it's perfectly fine. But that being said, I got to jump because I'm already late for a meeting. But you were all amazing. Thank you so much for the kind words. Thank you so much, Gabby, for suggesting this topic. And I will see y'all in the Discord. Take care.